Hello everyone, welcome back and search my channel as Dr. K. McCoy. In this session, I am going to discuss about the vapor compression refrigeration VCR. Vapor compression refrigeration is very important type of the refrigeration system, and why it is very important because of its application. At the end of this video, I am going to discuss what are the applications are there, why it is a very important type of the refrigeration system. And we'll discuss in this one vapor compression refrigeration principle, working applications. Moving to next, the first we will take the principle. This vapor compression refrigeration VCR, in which the refrigerant undergoes a phase change. Okay, the phase change from the liquid to vapor and vapor to liquid taking place in this one vapor compression refrigeration system. And also the vapor is compressed. When it is in the form of vapor, that is compressor. That's why it's called as a vapor compression refrigeration. Then what are the parts it consists? It consists of a evaporator, compressor, condenser and expansion valve. With this flow diagram, we can explain the principle of working of vapor compression refrigeration. First we will take the what are the parts are there. This is the evaporator, that is evaporator coil tubes, this one. Then in this one fairly dry refrigerant vapor at low pressure it is flowing here. Then next comes this whatever the compression section, this one from this refrigerant is flowing. Then after that this is a compressor delivery and this hermetically sealed compressor unit, this one. Both the compressor as well as motor are sealed, that's why it is called as hermetically sealed, in order to avoid that one whatever the leakage of the refrigerant. And this is the motor for that compressor. Then here the dry refrigerant vapor at high pressure. At the outlet of this compressor, the dry refrigerant vapor at high pressure it will be there. And this is the condenser, the refrigerant flow in the liquid form. And high pressure liquid refrigerant approximately at room temperature is flowing. And this is the throttle or expansion valve. And this is liquid refrigerant partially vapor at low pressure and temperature and pressure. And this is the freezing compartment. The principle how we can explain that one by taking first evaporator. In this evaporator, while flowing the refrigerant in the liquid state, it receives the heat from the outside space and get evaporated. As the refrigerant already having the low boiling point temperature, therefore it will get evaporates by receiving the heat from the outside space, which is to be cooled. And therefore at the end of this evaporator, the refrigerant will be in the vapor form. That is a fairly dry refrigerant vapor at low pressure that will be entering to this compressor. In this one, this is a reciprocating compressor is used in order to compress the vapor, and the vapor is compressed to a higher pressure and temperature. After the compression, the dry, high temperature, high pressure vapor will be entering to the condenser. The condenser is the heat exchanger, where due to that high pressure, the heat will be rejected to the outside atmosphere, outside air. Okay, then its temperature will be reduces. Its temperature is below its condensation temperature. Therefore, it will form a liquid of the refrigerant while flowing through the condenser. At the end of this condenser, the refrigerant will become a liquid refrigerant, and this is the refrigerant. We can see due to the higher compression, the high pressure liquid refrigerant approximately at room temperature will be flowing to the throttle valve. In the throttle valve, it will be expanded, that is suddenly expanded to the larger space. Therefore, that will be partially evaporated, and both its temperature and pressure will be decreases. And low temperature, low pressure, partially evaporated refrigerant goes to the again evaporator coils. The evaporator coils also heat exchanger, which will receive the heat from the outside space, and that refrigerant will be get evaporated, and that goes to the compressor again. And then after that compression, it goes to the condenser, expansion valve and evaporator. Like this, the cycle will continue till the required temperature attains at the cooling space. and here we are going to apply the external work. We are going to supply the external work to the compressor. By that we can receive the heat from the lower temperature space and reject to the outside higher temperature atmosphere. That is the principle of vapor compression refrigeration. Next we'll go for the working of vapor compression refrigeration. In this one, first again we'll start with the evaporator. In the evaporator, the liquid refrigerant, which is in the green, it is shown, okay, the low pressure liquid, and that while flowing through that one, it receives the heat from the outside space, and that will be get evaporated, and that becomes a LO here. LO, whatever the LO is there, low pressure gas. It is the low pressure vapor. It is vapor of the refrigerant. That is a low pressure gas, and that goes to this one through the different valves, and then that enters into a compressor. In this compressor, it will be get compressed to a higher pressure and higher temperature. This high pressure and high temperature, whatever the refrigerant is there, gas is there, that goes to the condenser. This we can see the high pressure gas. That goes to the condenser, where it is a heat exchanger. It rejects the heat to the outside atmosphere, and due to that higher pressure, then it will becomes a liquid by condensing. Okay, at the end of the condenser, the liquid refrigerant will be formed, and that goes to through the different valves and receiver, goes to the expansion valve here. And in the expansion valve, it expands to the suddenly due to that one, the pressure as well as the temperature both will be decreases, and then goes to the evaporator and compressor, condenser and expansion valve. Like this, in the working in the cycle, the low, whatever the from the low temperature space, heat will be received and rejected to the higher temperature atmosphere. Okay, by that we can provide the cooling effect to the in the particular region or a space. Then next, very important, that one I told you this, the vapor compression refrigeration is very important because of that one, its applications. The applications are the food processing, preservation and distribution. The domestic application as well as the hotel and the food processing industries and food transportation, all there it is used, that one. Okay. Then chemical and process industries, the some chemicals and some food processing, there also it is used. Then pharmaceutical industries, all the medicines what are there, okay, its production, storage, distribution, in all the applications it will be used. Some other special applications also we can use this refrigeration system. Comfort air conditioning, as we know that by the vapor compression refrigeration, the some space is cooled. If the space cooling is the room, then the comfort air conditioning we can have from it. Okay, that is the comfort air conditioning, also the refrigeration system we are going to use. And this is one of the refrigeration system, that is a vapor compression refrigeration system. Another refrigeration system is that one, vapor absorption refrigeration system, and that I am going to discuss in my next video. And thanks for watching, and search me as Dr. K. Makkode and subscribe and continue watching other videos also. Thank you.